Hello and welcome back to another math lesson hosted by Book&Table. I am your math tutor, Maurice Wright, and this video is problem set number 1 for the How to Solve Inequalities chapter. We are going to complete 27 questions in this practice set. You'll have a chance to create the interval notations for some number lines. You'll have a chance to solve a few inequalities and check your answer. We'll also have some problems that involve removing the absolute value sign and solving for x. Remember, should you have any follow-up questions, feel free to leave them in the comments section or contact a tutor in your area by visiting bookandtable.com or by downloading our app on the App Store. Let's kick things off. Question number 1. What inequality does this number line represent? Pause the video, solve this question, and then press play when you are ready. So step 1, we go to this circle and we draw a dotted line from the circle down to the number line. This helps us establish a value of -2 for the smallest point. Step 2, we want to determine if the circle is filled or empty, and we see that we are provided with a filled circle. And then step 3, determine which direction the arrow is pointing. If an arrow is pointing to the left, that represents values less than this value at -2, but the arrow is to the right, which represents the values greater than -2. Remember, along the number line, the values get larger. So we go from -2 to -1 to 0 to +1, +2, so on and so forth. So again, the answer to question number 1 is x is greater than or equal to -2. Let's take a look at question number 2. What inequality does this number line represent? This one right here. Pause the video. Solve this question, and then press play when you are ready to begin. Step 1, draw a dotted line from the circle down to the number line. This helps us establish a value of -3 at this end of the number line. Step 2, determine if the circle is filled or empty. We have an empty circle, which means our values will go up to -3, but will not include -3. Step 3, determine which direction the arrow is pointing. Since this arrow is pointing to the left, that represents the values less than -3. The values get more and more negative towards the left. -3, -4, -5, so on and so forth. So this represents x is less than -3. Question number 3. Now we have a compound inequality. So we have a circle on each end. What is the interval notation for this number line? Pause the video, solve this question, and then press play when you are ready to begin. So step 1, draw a dotted line from the first circle down to the number line. This helps us establish a value of -3 for this circle. So because of this, we see that we have a value of -3 as the smallest value in this set. Our line is going to the right, which means the values are getting greater, which means -3 is the smallest value in our set. And since we're writing it in interval notation, step 3 is we want to represent the smallest value in our set with -3, and we place a bracket to the left of the -3. That means -3 is the smallest value in the set, and the bracket represents that -3 is included since the circle is filled. And then we move on and do the same exact thing for this circle further to the right. So step 4, draw a dotted line from the second circle down to the number line. This helps you establish a value of 4 for this circle. Step 5, determine if the circle is filled or empty. And we see here that again, we are provided with a filled circle, which means that the largest value in this set is at positive 4. So we have the first value in our set, negative 3 with a bracket, since it's included. A comma goes between our two values. The largest value in our set should be the second number, which in this case is 4. In step 6, we place a bracket to the right of the 4, since positive 4 is included in our set. So this would be the answer to question number 3. Let's now have a look at question number 4. What is the interval notation for this number line? Pause the video, answer this question, and then press play when you are ready. Step 1, draw a dotted line from the first circle down to the number line. And step 2, determine if the circle is filled or empty. This helps us establish that we're going to have values that go down to but do not include positive 1, which means the first part of our answer is parenthesis 1, does not include 1, 1 being the smallest value. So step 3 is to place a parenthesis to the left of the 1 with our comma to separate the first value and the second value. Step 4, draw a dotted line from the second circle down to the number line. So this helps us establish that the largest value in this set is 5. So it's the values larger than positive 1 but not including 1, so parenthesis 1, all the way up to and including 5, which means step 5, once we determine that the circle is filled, step 6 is to place a bracket to the right of the number 5, the second and largest value in this set. So the interval notation for this number line is parenthesis 1, comma, 5 bracket. Question number 5. So now you are provided with an inequality and you want to represent the inequality on a number line. So the inequality for question number 5 is x is less than 4. Pause the video, draw this number line, and then press play when you are ready. So step 1, place an empty circle above 4 on the number line. The reason, we know the values that we're representing are less than 4 but not equal to 4. So since it's not equal to 4, it has to be an empty circle. So that's the first step. And then the second step, since it's the values less than 4, the values decrease as you move to the left along the number line. So step 2 is to draw an arrow to the left of the circle. So this arrow would represent the inequality x is less than 4. Let's now move on to question number 6. Represent the inequality on a number line. X is greater than or equal to 7. Pause the video, answer this question, and then press play when you are ready. Step 1. Place a filled circle above 7 on the number line. The circle should be filled since the expression says greater than or equal to. So since 7 is included, you want the circle to be filled, not empty. And since the expression says greater than 7, the numbers on the number line get larger as you move to the right. So step 2, draw an arrow to the right of the circle, and that will give you the answer to question number 6. Let's take a look at question number 7. Represent the inequality on a number line. X is less than or equal to -3. Pause the video, answer this question, and then press play when you are ready. Step 1. Place a filled circle above -3 on the number line. It is filled since x can equal -3. Step 2. Draw an arrow to the left of the circle. We go to the left since it is less than, and the numbers get smaller as you move from right to the left along the number line. So this would be the answer to question number 7. Let's move on to question number 8. Now we have a compound inequality. Represent the inequality on a number line. -4 is less than x, which is less than or equal to 2. Pause the video, answer this question, and then press play when you are ready. Step 1. Place an empty circle above -4 on the number line. That's because -4 is the smallest value in our compound inequality, so we start furthest to the left. It is empty since it is less than, but does not equal or cannot equal -4. So we have an empty circle above -4. We then draw the circle that represents the largest value in our compound, which is x is less than or equal to 2. So since it can equal 2, we place a filled circle above 2 on the number line. And then to finish, step 3, we connect the two circles with a straight line. So this is how we would represent our inequality on a number line. Let's take a look at question number 9. Represent the inequality on a number line. X is less than or equal to -2, and x is greater than 3. Pause the video, answer this question, and then press play when you are ready to begin. So if you're provided with two separate statements, go ahead and draw the number line for each one. So step 1, we're going to work here with this first expression. X is less than or equal to -2. So that means step 1, we want to place a filled circle above -2 on the number line. Step 2, we want to draw an arrow to the left of the circle since it is less than. So this is how we represent the first expression. X is less than or equal to -2. And then we represent the second expression. X is greater than 3. So we see in this question, our x values are disconnected. If the arrows were facing each other, then you would connect these two circles with a straight line. But in this case, they're pointing away from each other, which means we have two different sets that represent our x values. This second set is x is greater than 3. Step 3, we place an empty circle above 3 on the number line. And step 4, we draw an arrow to the right of the circle since it is greater than. So this would be the answer to question number 9. Let's take a look at question number 10. Represent the inequality on a number line. X is greater than or equal to -4, and x is less than 6. Pause the video, answer this question, and then press play when you are ready. So we are provided with two expressions where the values get larger. X is greater than or equal to a negative value, and x is less than a value that is larger than this. Since these values are heading towards the right and these values are heading towards the left, that's the clue that lets you know that you can combine these into a conjunction. So those two expressions are equivalent to -4 is less than or equal to x, which is less than 6. But let's say you weren't 100% aware of that to begin. You still start the same way you would before. So start with this expression here. X is greater than or equal to -4. Step 1, place a filled circle above -4 on the number line. It's filled because it can equal it. And step 2 is we're going to draw an arrow to the right since x is greater than. So once we do steps 1 and 2, we wind up with this. A filled circle above -4 and an arrow to the right. And then we go to our second expression, x is less than 6. So step 3, place an empty circle above 6 on the number line. Step 4, we want to connect the two circles with a straight line. Again, we were going to draw this line to the left, but since we have this circle over here with a line going to the right, we connect the two of them, and this winds up being the answer to question number 10. Let's take a look at question number 11. We are now going to solve an inequality. Solve for x and check the answer. -3x plus 1 is greater than or equal to 10. Pause the video, answer this question, and then press play when you are ready. So when we are solving an inequality, the first thing we want to do is remove the constant that is on the same side as the variable that we are solving for, which in this case is x. So our constant on the side of x is +1. So step 1, remove the constant by subtracting 1 from both sides. +1 and -1 cancel each other out, leaving us with -3x on the left side. And on the right side, we have 10 minus 1, which gives us 9. The next step, we want to remove the coefficient, which would be -3. So step 2, we remove the coefficient by dividing both sides by -3. When we do that, we wind up with x on the left side, and 9 divided by -3 gives us -3. And since we are dividing by a negative number, we have to reverse the inequality sign from greater than to less than. So the answer to question number 11 is x is less than or equal to -3. Now we want to check this answer. So we do that, step 3, by plugging two numbers into the original inequality. -3x plus 1 is greater than or equal to 10. Now, to confirm that this is the answer we're looking for, we want to plug in -3 because that should lead to a true statement, since according to our answer, x can equal -3. But then we also want to plug in a number that should not work. So since x is supposed to be less than -3, we're going to plug in a number that is larger than -3. So we'll plug in -2 as our second number. So the first number we'll plug in is -3. So when we plug -3 in for x, we get -3 times -3, which is +9. 9 plus 1 is 10. So that gives us a true statement. 10 is greater than or equal to 10. So x can equal -3. So we plug in -2 to show that x must be smaller, not larger than -3. When we plug in -2 for x, we get -3 times -2, which is +6. 6 plus 1 is 7. And that gives us the false statement, 7 is greater than or equal to 10. That is not true. So this confirms that the answer to question number 11 is x is less than or equal to -3. Solve for x and check the answer. 4x minus 7 is less than 13. Pause the video, answer this question, and then press play when you are ready. Step 1, remove the constant, which is -7, by adding 7 to both sides. By doing so, we wind up with 4x on the left side and 13 plus 7, which is 20 on the right side. And now we want to get rid of the coefficient attached to x. So step 2, remove the coefficient, 4, by dividing both sides by 4. That gives us x on the left side and 20 divided by 4, which is 5 on the right side. And since we're dividing by a positive number, we keep the sign the same, giving us an answer of x is less than 5. Now we want to check this answer. We check the answer by plugging two numbers into the original inequality, which is 4x minus 7 is less than 13. When we do so, we want to plug in a number that is less than 5 to show that it would work, and then we want to plug in 5 to show that it would not work. So we'll plug in 4, and then we'll plug in 5. When we plug in 4 for x, we wind up with 4 times 4, which is 16. 16 minus 7 would give you 9. And that leaves us with a true statement. 9 is less than 13. So x can be less than 5. Now we want to plug in 5 to show that 5 would not work. 4 times 5 would give you 20. 20 minus 7 is 13, leaving you with the false statement, 13 is less than 13. That is not true. So that confirms that the answer to question number 12 is x is less than 5. Question 13. Solve for x and check the answer. 2x over 5 minus 2 is less than 14. Pause the video, answer this question, and then press play when you are ready. Step 1, remove the constant, -2, by adding 2 to both sides. That leaves you with 2x over 5 on the left side and 14 plus 2, which is 16 on the right side. Now we want to negate the coefficient of x, which should be 2/5. So we remove the coefficient by multiplying both sides by the reciprocal of the coefficient. The reciprocal is the fraction you get when you switch the numerator and the denominator. So if we switch the 2 and the 5, we'd get 5/2. 5/2 times 2/5 would cancel each other out, leaving you with just x on the left side. 16 times 5 equals 80. 80 divided by 2 is 40. So we get x is less than 40. Step 3, we want to check the answer by plugging two numbers into the original inequality. So I'm going to plug in 35 rather than 39, just so we wind up with a whole number. So when we plug in 35 for x, we wind up with 2 times 35, which is 70. 70 divided by 5 would give us 14. 14 minus 2 gives us 12, leaving us with the true statement, 12 is less than 14. Now we want to plug in 40 to show that 40 would not work. 2 times 40 is 80. 80 divided by 5 would give you 16. 16 minus 2 gives you 14, leaving you with the false statement, 14 is less than 14. That would not be true. So the answer to question 13 is x is less than 40. Question number 14. Solve for x and check the answer. -3x over 4 minus 5 is greater than 7. Pause the video, answer this question, and then press play when you are ready. Step 1, remove the constant, -5, by adding 5 to both sides. That leaves us with negative 3x over 4 on the left side and 7 plus 5, which is 12 on the right side. Step 2, we want to remove the coefficient, negative 3/4, by multiplying both sides by the reciprocal, which would be negative 4/3. This cancels out our coefficient, leaving us with just x on the left side. 12 times negative 4 gives us negative 48. Negative 48 divided by 3 gives us negative 16. But since the negative is involved, we want to reverse our sign from greater than to less than. So the answer to question 14 again is x is less than negative 16. And we check the answer by plugging two numbers into the original inequality. Negative 3x over 4 minus 5 is greater than 7. For a value less than negative 16, I'm going to plug in negative 20 since it is a multiple of 4. Negative 3 times negative 20 gives us positive 60. 60 divided by 4 is 15. 15 minus 5 is 10, leaving us with the true statement, 10 is greater than 7. So a number smaller than negative 16 does work. Let's now plug in negative 16 to show that it would not work. Negative 3 times negative 16 is positive 48. Positive 48 divided by 4 is 12. 12 minus 5 is 7, leaving us with the false statement, 7 is greater than 7. So that confirms that the answer to question 14 is x is less than negative 16. Question 15. Solve for x and check the answer. Negative 5 is less than or equal to x plus 2, which is less than 7. Pause the video, answer this question, and then press play when you are ready. Step 1. Remove the constant by subtracting 2 from all three terms. When we do that, we wind up with negative 5 minus 2, which is negative 7 on the left side. We bring down the sign, less than or equal to. Positive 2 and negative 2 cancel out, leaving us with just x in the middle. And we wind up with 7 minus 2, which is 5 on the right end. So the answer to question 15 is negative 7 is less than or equal to x, which is less than 5. Step 2, check the answer by plugging 4 numbers into the original inequality. We're going to check our answer twice essentially. We're going to plug in 2 numbers from this end and 2 numbers from this end. When we're testing the lower end, we want to test out negative 8 since that should not work. It's on the outside of this set. And we want to test negative 7 since that should work. X can equal negative 7. So when we plug in negative 8 for x, we wind up with negative 8 plus 2, which is negative 6 in the middle, leaving us with this false statement. Negative 5 is less than or equal to negative 6. So since that is not true, we know that negative 8 cannot work, which is what we were expecting. Now let's plug in negative 7, which should work. Negative 7 plus 2 leaves you with negative 5 in the middle. And we wind up with a true statement. Negative 5 is less than or equal to negative 5, which is less than positive 7. So those two values help us confirm that this end of our answer is correct. Let's now test this end by plugging a number that should work, which would be positive 4. It's on the inside of this set. And then plug in positive 5, which should not work, since x cannot equal 5. So when we plug in 4, we wind up with 4 plus 2, which gives us 6 in the middle, leaving us with the true statement. Negative 5 is less than or equal to 6, true. And 6 is less than 7, which is also true. And then for the last number we plug in, which would be 5. 5 plus 2 is 7. That leads to the false statement, 7 is less than 7. So this confirms that the answer to question number 15 is negative 7 is less than or equal to x, which is less than 5. Question number 16. Solve for x and check the answer. Negative 8 is less than negative 2x minus 6, which is less than positive 2. Pause the video, answer this question, and then press play when you are ready. Step 1, remove the constant by adding 6 to all three terms. When we do that, we wind up with negative 8 plus 6, which is negative 2 on the left side, is less than negative 2x in the middle, which is less than 2 plus 6, which gives you 8 on the right. Now we want to remove the coefficient negative 2 by dividing all three terms by negative 2. Negative 2 divided by negative 2 is 1. Negative 2 divided by negative 2 is 1, leaving you with just 1 times x, which is x. And 8 divided by negative 2 gives us negative 4, leaving us with this statement. But to write this conventionally, we want the smallest value on the left and the larger value on the right. So negative 4 is less than x, which is less than 1, is the same as if we turn this statement around. Negative 4 is less than x. Negative 4 is less than x. And then x is less than 1. X is less than 1. So the answer that we get for question number 16 is negative 4 is less than x, which is less than 1. And now step 3, check the answer by plugging 4 numbers into the original inequality. When we do so, we test the smallest end by first testing a number that should not work, which would be negative 4. And then we plug in a number that should work, which would be negative 3, since that's inside of this set here. So when we plug in negative 4 for x, we wind up with negative 2 times negative 4, which is positive 8. 8 minus 6 gives us positive 2, leaving us with the false statement, 2 is less than 2. So this is false, as we were expecting. Negative 4 does not work. Now let's plug in negative 3. Negative 2 times negative 3 is positive 6. 6 minus 6 is 0, leaving us with the true statement, negative 8 is less than 0, which is less than 2. So by plugging in negative 4 and negative 3, we see that this end does work. Now let's plug in 0, which should work, and then plug in 1, which should not work. When we plug in 0, negative 2 times 0 is 0. 0 minus 6 is negative 6, leaving us with the true statement, negative 8 is less than negative 6, which is less than 2. And now we plug in 1. Negative 2 times 1 is negative 2. Negative 2 minus 6 is negative 8, leaving us with the false statement, negative 8 is less than negative 8. So that confirms that the answer to question number 16 is negative 4 is less than x, which is less than positive 1. Question number 17. Solve for x and check the answer. 7 is less than or equal to 2x plus 5, which is less than 15. Pause the video, answer this question, and then press play when you are ready. Step 1, remove the constant, positive 5, by subtracting 5 from all three terms. That leaves you with 7 minus 5, which is 2 on the left end. Less than or equal to comes down. 5 and negative 5 cancel out, leaving you with 2x in the middle. And 15 minus 5 leaves you with 10 on the right side. Now we want to remove the coefficient, positive 2. So we divide all three terms by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. Leaving us with 1 is less than or equal to x, which is less than 5. And now step 3, check the answer by plugging 4 numbers into the original inequality. To test the lower end of our answer, we first want to plug in a number outside of the inequality that should not work. So a number less than 1 would be 0. And then we want to plug in 1, which should work. X can equal 1. So when we plug in 0 for x, we wind up with 2 times 0, which is 0, plus 5 would be 5, leaving us with the false statement, 7 is less than or equal to 5. So 0 does not work for x. And now when we plug in 1 for x, we wind up with 2 times 1, which is 2. 2 plus 5 is 7, leaving us with the true statement, 7 is less than or equal to 7, which is less than 15. So this end of our answer is correct. And now to check this end, we want to plug in 4, since 4 is less than 5. And then we want to plug in 5, because 5 should not work, since x is less than 5, but not equal to 5. So when we plug in 4, 2 times 4 is 8. 8 plus 5 is 13, giving us the true statement, 7 is less than or equal to 13, which is less than 15. And then when we plug in 5, 2 times 5 is 10. 10 plus 5 is 15, leaving us with the false statement, 15 is less than 15. So this confirms that the answer to question number 17 is 1 is less than or equal to x, which is less than 5. Question number 18. Solve for x and check the answer. 3x plus 1 is less than 5, or negative 2x minus 3 is greater than or equal to 5. Pause the video, answer this question, and then press play when you are ready. So for this question, you are provided with 2 different inequalities, or a disjunction. For these, you want to solve the inequalities separately and check the answer separately. So step 1, solve the first inequality for x. The first inequality was 3x plus 1 is less than 5. So we first want to remove the constant by subtracting 1 from both sides, leaving us with 3x on the left side and 4 on the right side. To get rid of this coefficient 3, we divide both sides by 3, giving us an answer of x is less than 4/3. So now we want to check the answer by plugging 2 numbers into the original inequality. So since x is less than 4/3, we first want to plug in a number smaller than 4/3, which is 1, and that should work. And then we want to plug in a number larger than 4/3, which would be 2, and that should not work. So when we plug in 1, 3 times 1 is 3. 3 plus 1 is 4, leaving us with the true statement, 4 is less than 5. So x can be less than 4/3, but it should not be larger than 4/3, so 2 should not work. 3 times 2 is 6. 6 plus 1 is 7. Leaving us with the false statement, 7 is less than 5. So the first part of our answer is x is less than 4/3. And now we want to solve the second inequality that we were given. So step 3, solve the second inequality for x. We add 3 to both sides to cancel the constant, leaving us with negative 2x on the left and 5 plus 3, which is 8 on the right. To get rid of this coefficient, negative 2, we divide both sides by negative 2, leaving you with x on the left side. 8 divided by negative 2 is negative 4 on the right side. And since we divided by a negative number, we want to reverse our sign from greater than to less than or equal to. So the answer to question 18 is x is less than or equal to -4. And now we check this answer by plugging two numbers into the original inequality. So since x is supposed to be equal to or less than -4, we want to plug in -4 to make sure that that does work. And then we want to plug in a number that should not work. So since x can be less than -4, we want to go the opposite direction and plug in a number that is larger. So the second number we'll use is -3. When we first plug in -4, we get -2 times -4, which is 8. 8 minus 3 is 5, leaving us with the true statement, 5 is greater than or equal to 5. We then plug in -3 for x, leaving us with -2 times -3, which is +6. 6 minus 3 gives us 3, leaving us with the false statement, 3 is greater than or equal to 5. So this confirms the second part of our answer to question 18, which is x is less than or equal to -4. Let's take a look at question number 19. Solve for x and check the answer. -5x plus 3 is greater than or equal to 18, or 2x minus 1 is less than 7. Pause the video, answer this question, and then press play when you are ready. Step 1, solve the first inequality for x. Since we want to solve for x here, we first want to remove this constant +3 by subtracting 3 from both sides, leaving you with -5x on the left side and 18 minus 3, which is 15 on the right side. Then we want to get rid of this coefficient, -5, so we divide both sides by -5, giving us x on the left side. 15 divided by -5 is -3 on the right side. And since we divided by a negative number, we reverse our sign from greater than or equal to less than or equal to. So the answer to question number 19 is x is less than or equal to -3. And then step 2, check the answer by plugging two numbers into the original inequality. -5x plus 3 is greater than or equal to 18. And when we do so, we first want to plug in -3 since that should work. And then we plug in -2 since that should not work. When we plug in -3 for x, we get -5 times -3, which is 15. 15 plus 3 is 18, leaving a true statement. 18 is greater than or equal to 18. We then plug in a number that should not work, -2. -5 times -2 is +10. 10 plus 3 is 13, leaving us with a false statement. 13 is greater than or equal to 18. You then go on and solve the second inequality you were provided with. 2x minus 1 is less than 7. So step 3, solve the second inequality for x. So we first add 1 to both sides to get rid of this constant, -1. That leaves you with 2x on the left side and 7 plus 1, which is 8 on the right side. We then want to get rid of this coefficient 2. So we divide both sides by 2, leaving us with x on the left side and 8 divided by 2, which is 4 on the right side. So the answer to the second part of question number 19 is x is less than 4. So step 4, check the answer by plugging two numbers into the original inequality. 2x minus 1 is less than 7. When we do so, we first want to plug in 3 since 3 is less than 4, and that should work. And then we want to plug in 4 since 4 should not work. So when we plug in 3 for x, we get 2 times 3, which is 6. 6 minus 1 is 5, leaving you with the true statement, 5 is less than 7. When we plug in 4 for x, we get 2 times 4, which is 8. 8 minus 1, which is 7. leaving you with the false statement, 7 is less than 7. So that confirms that the second part to question number 19 is x is less than 4. Question number 20. Solve for x and check the answers. The absolute value of negative 2x minus 5 is less than 9. Pause the video, answer this question, and then press play when you are ready. Step 1. Remove the absolute value sign by creating a conjunction with the negative value of the expression. So when you have the absolute value sign accompanied with less than, you take the positive value you were given and give it a negative value on the left side of what is now a compound inequality or a conjunction. So after step 1, we no longer have our absolute value sign and we have a conjunction. And now step 2 is going to be to solve this inequality for x. So we first remove this constant negative 5 by adding 5 to all three terms, leaving us with negative 9 plus 5, which is negative 4 on the left side. Negative 2x comes down. 9 plus 5 gives us 14 on the right side. And now we want to get rid of this coefficient, negative 2. So we divide all three terms by negative 2, leaving us with negative 4 divided by negative 2, which is positive 2. 14 divided by negative 2 gives us negative 7. And since we are dividing by a negative number, we have to reverse our signs from less than to greater than. When we do so, we reverse this. So we get negative 7 is less than x, which is less than 2. Negative 7 is less than x, which is less than 2. So this would be our answer to question number 20. And now we check this answer by plugging 4 numbers into the original inequality. The 4 numbers, we'll plug in 2 values on this end and 2 values on this end. On the lower end, negative 7 should not work. Negative 6 should work. When we plug in negative 7 for x, negative 2 times negative 7 is 14. 14 minus 5 is 9. The absolute value of 9 is 9, leaving you with the false statement, 9 is less than 9. So negative 7 does not work for x, which we are expecting. X does not equal negative 7, but negative 6 should work. Negative 2 times negative 6 is positive 12. 12 minus 5 is 7. The absolute value of 7 is 7, leaving you with the true statement, 7 is less than 9. So those two numbers show that this end of our answer is correct. Now let's plug in 2 numbers from this end. If we plug in 1, 1 is less than 2, so that should work. And then if we plug in 2, that should not work, since x is less than 2, but it cannot equal 2. So when we plug in 1, negative 2 times 1 is negative 2. Negative 2 minus 5 is negative 7. And the absolute value of negative 7 is 7, leaving you with the true statement, 7 is less than 9. And now when we plug in 2 for x, negative 2 times 2 is negative 4. Negative 4 minus 5 is negative 9. And the absolute value of negative 9 is 9, leaving you with the false statement, 9 is less than 9. So this confirms that the answer to question number 20 is negative 7 is less than x, which is less than positive 2. Let's take a look at question number 21. Solve for x and check the answer. The absolute value of 4x minus 3 is less than or equal to 13. Pause the video, answer this question, and then press play when you are ready. We have the absolute value sign accompanied with less than, which means step 1, remove the absolute value sign by creating a conjunction with the negative value of the expression. So the positive value is 13. If we make this negative, it'd be negative 13. And we create a conjunction. Negative 13 is less than or equal to 4x minus 3, no absolute value sign, which is less than or equal to 13. And once we have our inequality set up, step 2, we want to solve for x. So we first get rid of this constant, negative 3, by adding 3 to all three terms. Negative 13 plus 3 leaves you with negative 10 on the left side. 4x comes down. 13 plus 3 is 16 on the right side. And now to get rid of this coefficient of 4, we divide all three terms by 4. Negative 10 divided by 4 is negative 2.5. Get x in the middle. 16 divided by 4 is 4. So the answer that we get is negative 2.5 is less than or equal to x, which is less than or equal to 4. Step 3, check the answer by plugging 4 numbers into the inequality. So to test the lower end of this answer, we first want to plug in a number smaller than negative 2.5. So we'll plug in negative 3, which should not work. And then we'll plug in negative 2.5, which should work. So when we plug in negative 3 for x, we get 4 times negative 3, which is negative 12. Negative 12 minus 3 gives you negative 15. And the absolute value of negative 15 is 15. Leaving you with the false statement, 15 is less than or equal to 13. And now we plug in negative 2.5 for x. 4 times negative 2.5 gives you negative 10. Negative 10 minus 3 gives you negative 13. And the absolute value of negative 13 is 13. Leaving you with the true statement, 13 is less than or equal to 13. So those two numbers show that this end of the answer is correct. This side of the answer. So first let's plug in 4, which should work since x is allowed to equal 4. And then let's plug in 5, which should not work since x is supposed to be less than 4, not larger. So when we plug in 4 for x, we get 4 times 4, which is 16. 16 minus 3 is 13. And the absolute value of 13 is 13, leaving you with the true statement, 13 is less than or equal to 13. We then plug in 5 for x. 4 times 5 is 20. 20 minus 3 is 17. The absolute value of 17 is 17, leaving you with the false statement, 17 is less than or equal to 13. So this confirms that the answer to question 21 is negative 2.5 is less than or equal to x, which is less than or equal to 4. Question number 22. Solve for x and check the answers. The absolute value of negative 3x plus 7 minus 6 is less than or equal to 14. Pause the video, answer this question, and then press play when you are ready. Okay, so we first want to isolate our absolute value sign. So step 1, we want to get rid of this constant negative 6 by adding 6 to both sides. This leaves us with just our absolute value sign on the left side, which is negative 3x plus 7 is less than or equal to 14 plus 6, which is 20 on the right side. And now we can proceed from here the way we did with the previous questions. So step 2, remove the absolute value sign by creating a conjunction with the negative value of the expression. So the positive value is 20. So if we make that negative, we get negative 20. We remove the absolute value sign, keep our sign less than or equal to. And now we have the compound inequality that we want to solve for. So step 3, solve for x. So we first want to get rid of this constant, positive 7, by subtracting 7 from all three terms. Negative 20 minus 7 gives you negative 27 on the left side. Negative 3x comes down. And on the right side, 20 minus 7 is 13. To cancel this coefficient, negative 3, we divide all three terms by negative 3. Negative 27 divided by negative 3 is positive 9. X in the middle. 13 divided by negative 3 is negative 4 and 1/3, which is equal to negative 4.33. We had to reverse our signs from less than to greater than since we were dividing by a negative number. And since we have our smaller value on the left and larger value on the right, we can rotate this around. So negative 4.33 is less than or equal to x if you're reading it right to left. Negative 4.33 is less than or equal to x. X is less than or equal to 9. So if we turn this whole thing around, x is less than or equal to 9. So the answer to question number 22 is negative 4.33 is less than or equal to x, which is less than or equal to 9. And now step 4, check the answer by plugging 4 numbers into the original inequality. So we want to plug in 2 numbers from this end. We'll plug in negative 5 since that's smaller than negative 4.33, so it should not work. We'll then plug in negative 4.33. So if we plug in negative 5 for x, we get negative 3 times negative 5, which is 15. 15 plus 7 is 22. The absolute value of 22 is 22. 22 minus 6 is 16, leaving us with the false statement, 16 is less than or equal to 14. And now when we plug in negative 4.33 for x, we get negative 3 times negative 4.33, which gives you positive 13, plus 7 will give you positive 20. The absolute value of 20 is 20. 20 minus 6 is 14, leaving you with the true statement, 14 is less than or equal to 14. So that shows that this end of our answer is correct. Now to test this end, we want to plug in 9, which should work, and then 10, which should not work, since that would be larger than 9, not smaller than 9. When we plug in 9 for x, we get negative 3 times 9, which is negative 27, plus 7 gives you negative 20. The absolute value of negative 20 is 20. 20 minus 6 is 14, leaving you with the true statement, 14 is less than or equal to 14. When we plug in 10 for x, negative 3 times 10 is negative 30, plus 7 is negative 23. The absolute value of negative 23 is 23. 23 minus 6 is 17, leaving you with the false statement, 17 is less than or equal to 14, thus confirming that this is the correct answer to number 22. Negative 4 1/3 is less than or equal to x, which is less than or equal to 9. Question number 23. Solve for x and check the answers. The absolute value of 7x minus 3 plus 8 is less than 18. Pause the video, answer this question, and then press play when you are ready. So you first want to isolate your absolute value sign on one side of the inequality. So you want to get rid of the constant 8. So step 1, isolate the absolute value term by subtracting 8 from both sides. That leaves you with the absolute value of 7x minus 3 is less than 18 minus 8, which is 10. And now we have the absolute value sign with less than, which means we want to create a conjunction. So step 2, we remove the absolute value sign by creating a conjunction with the negative value of the expression, negative 10. That leaves us with the conjunction negative 10 is less than 7x minus 3, which is less than 10. So step 3, we want to solve for x. We get rid of the constant -3 by adding 3 to all 3 terms, leaving us with -10 plus 3, which is -7 on the left side. 7x comes down. 10 plus 3 is 13 on the right side. And now we want to negate this coefficient 7 by dividing all 3 terms by 7. -7 divided by 7 is -1. The x comes down. 13 divided by 7 is 1.85, leaving us with the answer -1 is less than x, which is less than 1.85. So now we want to check this answer by plugging 4 numbers into the original inequality. So we'll start by plugging in -1, which should not work, and then we'll plug in 0, which should work. When we plug in -1 for x, 7 times -1 is -7, minus 3 would give you -10. The absolute value of -10 is +10. 10 plus 8 is 18, leaving you with the false statement, 18 is less than 18. When we plug in 0 for x, 7 times 0 is 0. 0 minus 3 is -3. The absolute value of -3 is 3. 3 plus 8 is 11, leaving you with the true statement, 11 is less than 18. So those show that this end of our answer is correct. Now let's test this end of our answer. If we plug in 1, which is less than 1.85, we get 7 times 1, which is 7, minus 3, which is 4. The absolute value of 4 is 4. 4 plus 8 is 12, leaving you with the true statement, 12 is less than 18. If we plug in 2, which is larger than 1.85, 7 times 2 is 14. 14 minus 3 is 11. The absolute value of 11 is 11. 11 plus 8 is 19, leaving us with the false statement, 19 is less than 18, and thus confirming that the answer to question 23 is -1 is less than x, which is less than 1.85. Question number 24. We now have the absolute value sign and greater than. Solve for x and check the answers. The absolute value of 8x minus 2 is greater than 4. Pause the video, answer this question, and then press play when you are ready. Okay, when you have the absolute value sign accompanied with greater than, you're going to wind up with a disjunction as your answer. So 2 different inequalities that represent x, and these inequalities will not overlap. So the first value we need to solve for is the positive value of the absolute value sign. So step 1, we create the first inequality by removing the absolute value sign. So we just take the expression on the inside and leave the sign and the value the same. And now step 2, we solve for x. So we add 2 to both sides, giving us 8x is greater than 6. We then divide both sides by 8, giving us x is greater than 6 divided by 8, which is 0.75 or 3/4. So we get x is greater than 3/4 as the answer to the first inequality. So we put that to the side. And now to solve for the second inequality, in order to remove the absolute value sign, we first have to reverse the inequality sign from step 1. So we reverse it from greater than to less than, and we make the value of the inequality negative instead of positive. So now the second inequality that we need to solve for is 8x minus 2 is less than -4, and then you solve for x. So you add 2 to both sides, giving you 8x on the left side Negative 4 plus 2 is negative 2 on the right side. To get rid of this coefficient of 8, we divide both sides by 8, leaving us with x is less than negative 2 over 8 is negative 1/4, which is negative 0.25. So these are the two separate intervals for our x value. And now to check the answers, you plug in 4 numbers into the original inequality, 2 numbers to test this, 2 numbers to test this part. So we'll start with the smallest values and work our way up to the positive values. So starting with the negative part, x is less than negative 1/4. A value less than negative 1/4 is negative 1. So you plug in negative 1 for x, you get 8 times negative 1, which is negative 8. Negative 8 minus 2 is negative 10. The absolute value of negative 10 is 10, leaving us with the true statement 10 is greater than 4. So when x is less than negative 1/4, it does work, which we are expecting. Now if we plug in a value larger than negative 1/4, which would be 0, that should not work. 8 times 0 is 0. 0 minus 2 is negative 2. The absolute value of negative 2 is 2, leaving you with a false statement, 2 is greater than 4. So this part of the answer checks out. Now let's test this part. X is greater than 3/4. So if we test out 3/4 or 0.75, that should not work since it's supposed to be greater than this. 8 times 3/4 is 6. 6 minus 2 is 4, and the absolute value of 4 is 4, leaving you with the false statement, 4 is greater than 4. And now if we plug in a number larger than 0.75, which is 1, we get 8 times 1, which is 8. 8 minus 2 is 6. The absolute value of 6 is 6, leaving you with the true statement, 6 is greater than 4, and thus confirming that x is greater than 3/4 or x is less than negative 0.25 is the correct answer. Let's have a look at question number 25. Solve for x and check the answers. The absolute value of negative 5x plus 3 is greater than or equal to 23. Pause the video, answer this question, and then press play when you are ready. So when you have the absolute value sign accompanied with the greater than sign, the first thing you want to do is remove the absolute value sign and solve for x with the positive value. And then we're going to remove the absolute value sign again, reverse this inequality, and make this value negative, and then solve for x again. So first, we'll solve for the positive value. So step 1, create the first inequality by removing the absolute value sign. This is the first inequality we want to solve for. So step 2, solve for x. So negative 5x plus 3 is greater than or equal to 23. So the first thing you want to do is remove the constant by subtracting 3 from both sides, leaving us with negative 5x on the left. 23 minus 3 is 20 on the right. To get rid of the negative 5, we divide both sides by negative 5, leaving us with x. Reverse the sign since this is negative. Is less than or equal to 20 divided by negative 5 is negative 4. So x is less than or equal to negative 4 is the first part of our answer. So we'll put that to the side. Now, to remove the absolute value sign, as I mentioned a second ago, we have to reverse the sign from greater than to less than. And we have to make our positive value negative. This is now the second inequality we need to solve for. So step 5, solve for x. So we want to get rid of the constant positive 3 by subtracting 3 from both sides, leaving you with negative 5x on the left. Negative 23 minus 3 is negative 26 on the right. To get rid of the coefficient, negative 5, we divide both sides by negative 5, leaving us with x on the left. We're dividing by negative. Reverse this from less than or equal to greater than or equal to. And then negative 26 divided by negative 5, we give you 5.2, which is the same as 5 and 1/5. So the second part of our answer is x is greater than or equal to 5.2. So now step 6, check the answers by plugging 4 numbers into the original inequality. When we do so, we'll start off with our negative values and work up to our positive values. So x is less than or equal to negative 4. So we'll first plug in negative 4, which should work, and then we'll plug in negative 3, which should not work. When we plug in negative 4 for x, we get negative 5 times negative 4, which is positive 20. 20 plus 3 is 23. The absolute value of 23 is 23, leaving you with the true statement, 23 is greater than or equal to 23. When we plug in negative 3 for x, we get negative 5 times negative 3 is positive 15, plus 3 is 18. The absolute value of 18 is 18, leaving us with the false statement, 18 is greater than or equal to 23. So those two values prove that this part of our answer is correct. And now let's test this part of our answer. X is greater than or equal to 5.2. So a number that should not work is 5, since it's smaller than 5.2. When we plug in 5 for x, we get negative 5 times 5 is negative 25. Negative 25 plus 3 is negative 22. The absolute value of negative 22 is 22, leaving us with the false statement, 22 is greater than or equal to 23. And now if we plug in 5 and 1/5, or 5.2 for x, we get negative 5 times 5.2, which is negative 26. Negative 26 plus 3 is negative 23. The absolute value of negative 23 is 23. And 23 is greater than or equal to 23. And these show that this is the correct answer to question number 25. X is less than or equal to negative 4, or x is greater than or equal to 5.2. Question number 26. Solve for x and check the answers. The absolute value of 9x minus 4 plus 1 is greater than or equal to 15. Pause the video, answer this question, and then press play when you are ready. We need to isolate our absolute value term. So we want to get rid of this constant, positive 1, by subtracting 1 from both sides, leaving you with the absolute value of 9x minus 4 is greater than or equal to 14. And then once you have your absolute value sign isolated, you then, step 2, create the first inequality by removing the absolute value sign. And step 3, you solve for x. So we're going to add 4 to both sides, leaving you with 9x on the left side and 14 plus 4, which is 18 on the right side. We get rid of this coefficient 9 by dividing both sides by 9, leaving us with x is greater than or equal to 2. So the first part of our answer is x is greater than or equal to 2. We put that to the side. Now you reverse the sign, take the negative value of the inequality, and you remove the absolute value sign, and you solve for x. So we add 4 to both sides, leaving you with 9x on the left side, and negative 14 plus 4, which is negative 10 on the right side. To negate this coefficient of 9, we divide both sides by 9, leaving you with x on the left is less than or equal to negative 10 divided by 9 is negative 1.11. So now we have the two parts of our disjunction. We check the answer by plugging 4 numbers into the original inequality. So starting with the negative values, x is less than or equal to negative 1.11. So if we plug in negative 1.11 for x first, we get 9 times negative 1.11, which gives you negative 10. Negative 10 minus 4 gives you negative 14. The absolute value of negative 14 is 14. 14 plus 1 is 15, leaving us with the true statement 15 is greater than or equal to 15. So x can equal negative 1.11. If we plug in 0, which is greater than negative 1.11, not smaller, it should not work. 9 times 0 is 0. 0 minus 4 is negative 4. The absolute value of negative 4 is 4. 4 plus 1 is 5. And 5 is not greater than or equal to 15. So this part of our answer is correct. Now let's test out this part of our answer. X is greater than or equal to 2. So let's plug in a number smaller than 2, which is 1. That should not work. And then we'll plug in 2, and that should work. When we plug in 1 for x, 9 times 1 is 9. 9 minus 4 is 5. The absolute value of 5 is 5. Plus 1 is 6. Leaving us with the false statement. 6 is greater than or equal to 15. If we then plug in 2 for x, 9 times 2 is 18, minus 4 is 14. The absolute value of 14 is 14, plus 1 is 15, giving us a true statement, 15 is greater than or equal to 15, and thus confirming that these are the correct answers to question number 26. X is greater than or equal to 2, or x is less than or equal to negative 1.11. And now the last question of this practice set, number 27. Solve for x and check the answers. The absolute value of 2x over 5 plus 3 minus 6 is greater than negative 2. Pause the video, answer this question, and then press play when you are ready. Step 1. Isolate the absolute value term by adding 6 to both sides. This leaves you with the absolute value of 2x over 5 plus 3 is greater than 4. Now you have your absolute value term isolated. So you want to create the first inequality by removing the absolute value sign, and then you solve for x. Since we're adding 3 to the side, we want to subtract 3 from both sides, leaving you with 2x over 5 on the left, and 4 minus 3, which is 1 on the right. To negate the coefficient 2/5, you want to multiply both sides by the reciprocal, which would be 5/2. 1 times 5 is 5, divided by 2 is 5/2. 5/2 is the same as 2.5. So the first part of our answer is x is greater than 2.5. Put that to the side. Now we go back to the inequality where our absolute value term is on the left and we have a positive value of 4 on the right. So now we remove the absolute value sign. We reverse the inequality sign from step 2. And then step 5, we make the value of the inequality, which is positive 4, negative. So we wind up with negative 4, giving us the second inequality we want to solve for. So step 6, solve for x. To get rid of this constant, positive 3, we subtract 3 from both sides, leaving us with 2x over 5 on the left, and negative 4 minus 3, which is negative 7 on the right. To negate this coefficient of 2/5, multiply both sides by the reciprocal, 5/2. Negative 7 times 5 is negative 35, divided by 2 is negative 17.5. So the second part of our answer is x is less than negative 17.5. So now we check the answers by plugging 4 numbers into the original inequality. To start with our negative most values, a number less than negative 17.5 is negative 20. Since we're dividing by 5, this would just make things easier. 2 times negative 20 is negative 40. Divided by 5 is negative 8. Negative 8 plus 3 is negative 5. The absolute value of negative 5 is 5. 5 minus 6 is negative 1, leaving us with the true statement, negative 1 is greater than negative 2. We then want to test a second number. So negative 15 would be greater than negative 17.5. 2 times negative 15 is negative 30. Divided by 5 is negative 6. Negative 6 plus 3 is negative 3. The absolute value of negative 3 is 3. 3 minus 6 is negative 3, leaving us with the false statement, negative 3 is greater than negative 2. So this is true. To test x is greater than 2.5, we are first going to plug in 2.5 for x. 2 times 2.5 is 5. 5 divided by 5 is 1. 1 plus 3 is 4. The absolute value of 4 is 4. 4 minus 6 is negative 2, leaving us with the false statement, negative 2 is greater than negative 2. And then lastly, a number greater than 2.5, which should work, would be 3. 2 times 3 is 6. 6 divided by 5 is 1.2, or 1 1/5. 1.2 plus 3 is 4.2. The absolute value of 4.2 is 4.2. 4.2 minus 6 is negative 1.8, leaving us with the true statement, negative 1.8 is greater than negative 2, and thus confirming that the answer to question number 27 is x is greater than 2.5, or x is less than negative 17.5. So that wraps up practice set number 1 for solving inequalities. If you have any follow-up questions, feel free to leave them in the comment section. Or, of course, you can contact a tutor near you by visiting bookandtable.com or by downloading our app on the App Store. Peace.